In this lesson, I'm going to show you how to find the area of regular polygons, and our focus here would be pentagons. I'm going to introduce you to what a pentagon is, just in case you've forgotten, and then I will be showing you a new concept called the apothegm. We're going to look at the steps that we follow to find the area of the regular pentagon, and then we're going to walk through some examples together. So let's begin. A regular pentagon is a five-sided polygon, and the word regular here simply means that all the sides are equal. Also, it means that all the angles are equal. And so we can see here, approximately ABCDE is a regular pentagon. We're saying here that all these angles are equal. So let me do this right here to show that all these angles are equal. I'm going to draw a line just to show equality here, and then all the sides are also equal. All the sides are equal. So when you see a regular polygon, that's what it simply means. All sides are equal, all angles are equal. So let's now examine what an apothegm is. An apothegm of the polygon is a line segment from one of the sides of the polygon to the center of the polygon. So this is your apothegm. OM is your apothegm here, and you can see here that your apothegm is OM. So O right here is the center of the polygon, and one of the assumptions we make here is that this pentagon is inscribed in a circle, and from O to C and O to B and O to A is going to be the radius of that circle. So O is actually the center of the circle, and because the pentagon is inscribed in the circle, then O also becomes the center of the pentagon or any polygon that is inscribed in the circle. The other thing to remember here is the apothegm is also the altitude of the triangle. So if you form a triangle from the center of the polygon to any of the sides, so you have from O to B, O to A, so you can see that those are most likely going to be equal, and then you have OM is going to be the apothegm is going to be the altitude of the triangle ABO or OAB. And so this is a very important information, because we're going to use this to find the area of the pentagon. And so we can see here that the line segment OM is your apothegm. So now there are two different ways to go about finding the area of the pentagon. Both ways require you to find the length of the apothegm. So the first method is to find the length of the apothegm and then find the perimeter of the pentagon, and then you apply the formula below, and that formula is the area is 1/2 the perimeter of the pentagon multiplied by the length of the apothegm. And then the other method, and I'll show you why they're all the same. If you're not the type to memorize formulas, then this may not be one that you like. But here's another method. We're going to create a triangle from the center of the pentagon to one side of the pentagon. So we're going to form a triangle, something that looks like this. And we're going to find the apothegm here. So this is OM. Let's call this AB here. So if we find the apothegm right here, we have the height of the triangle, and AB is actually one of the sides of the pentagon. So you have that information. Now you're going to find 1/2 base times height for the area of the triangle, and then you're going to multiply it by the number of sides that you have for the pentagon, which is 5. And so you may see that this is actually similar to doing this right here, because the perimeter of your pentagon is going to be your AB multiplied by 5. So your B here multiplied by 5. Can you see that? And then your apothegm is your H right here. and then you're multiplying it by half. So you can see that it's all the same thing. It all depends on your approach to math. So let's go ahead and do some examples together. So find the length of the apothem of the regular pentagon below, given that tan 36 is 0.7 and tan 54 is 1.4. So one thing I want you to realize is we want to find out I'm going to draw a line from here to the center and another line from the center to right here. Let's approximate that this is straight. And then we're going to identify. Okay, we can see that the length of each side of the pentagon is going to be 14. So this is 14 right here. And so I'm going to approximate one triangle. I'm going to draw out one of the triangles. So we have a right triangle. Hopefully I can get something straighter. Okay, so I have this right here. Now, what is the angle for each of the, when you have a pentagon, remember that the pentagon has 180 n minus 2. The sum of all the angles is 180 n minus 2, and then we're going to divide by n. So let's go ahead and find what that is. 180 multiplied by n is 5 minus 2 divided by 5. So 180 multiplied by 3 divided by 5. This is going to give you 108 degrees. So you have 108 degrees for each of these right here, 108 degrees. And then we're going to have 54 degrees for this side here, 54 degrees for each side here. So now that your OM actually it actually cuts the triangle into two equal parts, the base of the triangle to two equal parts. So this is 7, this is 7. So actually, let's draw the triangle differently so that we can actually show it more clearly. And so I'm going to draw a triangle that it's going to be a long one like that, something that looks like that right here. And here we're looking for h, which is your apothem. This is 7, and then this is 54. So we're going to now apply our SOHCAHTOA. So our TOA is, we're going to use tan. The question kind of gives you a hint of what you're going to need. So tan 54 is equal to opposite, which is h, divided by adjacent, which is 7. So your h is equal to tan 54 multiplied by 7. Tan 54 is 1.4. We're going to multiply that by 7, which is 9.8. So that is going to be the length of our apothem. So you can see here something to also look as we proceed with further questions. You're going to see here that the height is going to be the tan of 54 degrees multiplied by half of the length of the side of the pentagon. So let's go ahead and look at some other examples here. Find the area of a regular pentagon given that the apothem is 4.2 inches and the length of one of the sides is 8. So the area of the the area of the pentagon is, you have two choices, 1/2 multiplied by perimeter of the pentagon multiplied by apothem. Okay, we're going to try that method and I'll try the other method as well. This is going to give us 1/2 multiplied by, the perimeter is going to be 8 multiplied by 5, because you have 5 sides, multiplied by 4.2. So this is going to give you, we're going to cross this out here. So this is 4 multiplied by 5 multiplied by 4.2. So 20 multiplied by 4.2. So 20 multiplied by 4.2, I have a 0 here, so it's going to be 2 multiplied by 42. So this is going to give you 84 inches. Now the other method is to remember that your apothem is the height of the triangle. So let's go ahead and draw a triangle here. So this is 8 right here, this is 4.2. And so we find out the area of this triangle first, which is 1/2 base times height. 1/2 of 8 multiplied by 4.2, which is 4 multiplied by 4.2, and you get 16.8. And then you have 5 sides, you multiply that by 5, and then you're going to get 84.0. So you end up with 84 inches. So you can see that regardless of the method you're going to use, you're always going to end up at the same answer. Next example, we're going to look at this pentagon. Tan 36 is 0.7, and tan 54 is going to be 1.4. So I showed you earlier that for each of these, for this pentagon, each of the angles is going to be 108 degrees. So how do you get to it? We have interior angle. Interior angle is going to be, well, let me say each interior angle is going to be 180 n minus 2 divided by n, which is 180 5 minus 2 divided by 5, and we have 180 multiplied by 3 divided by 5, which is going to give you 108 degrees. So this is 108 degrees, 108 degrees. I'm going to draw a line from here to here. Pardon my crooked drawing so far. So this is going to be 54 degrees, and this is going to be 36 degrees. So here we have our triangle right here is going to be, oh, that's bad. So let me actually draw a straight one. So our triangle is going to look like this. And so this is what our triangle is going to look like. Okay, this is an approximation. This is good enough. So we have this angle right here. This is going to give us 54 degrees. This is going to give us 36 degrees. And here, this is going to be M right here. This is going to be B, and this is O. This is going to be 14 units. So now let's go ahead and find the height. This is your apothem, which is your height here. And so let's go and find the height. So tan 36 degrees is going to be opposite, which is 14 divided by adjacent. So therefore, we have, actually I'm going to use 54. 54 is a lot easier to work with. Let me use 54. So tan 54 degrees is going to be equal to opposite, which is h, divided by adjacent, which is 14. So 1.4 is equal to h divided by 14. So h is 14 multiplied by 1.4, which is going to give you 19.6. So now let's find the area of this triangle. So we are going to go ahead and multiply. Find out the area is 1/2 base multiplied by height. So the triangle is now going to be 19.6, and then we have 28 over here. So it's going to be 1/2. Your base is 28. Your height is 19.6. So we're going to go ahead and simplify this. So let's go ahead and divide right here. So we have 28 multiplied by 9.8. Let me do that right here. Yeah, we can do that right here. So 28, and then we have 9.8. Let's multiply. 28 multiplied by 8 is 4. Bring 6 up here, 22. Put a 0 here. 8 multiplied by 9, 72. 2. Bring a 7 here. This is 25. Okay, so this is going to give you 4, 4, 7. So 2744, and we have one decimal right here. So the area of the triangle is 274.4, And so therefore, the area of the pentagon, is going to be 274.4 multiplied by 5, which is going to give you 1,372 units. Because we don't have a unit here, so we're just going to have 1,372 as our answer. Now we have a final question here. We want to find the area of the pentagon now that we have the apothem. All right, so let's go ahead and construct a triangle. And here's what our triangles, we're trying to finish this side out and finish this side out. So now we have a right triangle right here. So we're going to construct our right triangle that looks similar to that. So here's what our right triangle is going to look like. And okay, so our right triangle looks like this. We have 7 right here. We have 54 right here. We have 36 right here. And then we need to find the base. So I'm going to use 36 degrees in this case. So tan 36 degrees is going to be opposite, which is B, divided by your adjacent, which is 7. So B is equal to tan 36 multiplied by 7. Tan 36 is 0.7 multiplied by 7, which is 4.9. So your base is going to be, your base right here is going to be 4.9. So what we can do here is go ahead and find, well, we're going to multiply the base by 2 here to get the base of, to get the length of one of the sides of the pentagon, because this is going to be 4.9, this is going to be 4.9. So now we have a pentagon, we have another triangle. Let me draw another triangle just so you can see it. Let's draw another triangle. It's going to look like this. And we have, this is right here, and then this is also right here. So this is an approximation of what the triangle looks like. Okay, and this is our height right here. This is 7, this is 9.8, and so the area of this triangle is going to be, area of triangle is going to be half base times height, which is 1/2 9.8 multiplied by 7, which is going to give us 34.3 if you put this in your calculator. And now we have 5 sides, so we're going to multiply this by 5 to get the area of the pentagon. So 34.3 multiplied by 5, this is 510, actually it's going to be 171.5. If you put this in a calculator, you'll get 171.5. So therefore, the area of the pentagon, 171.5. So area of pentagon is going to be 171.5 units.